Hey guys, it's Miss Adams again, coming at you with a Unit 6B test review. We're now on to problem 15. We're going to solve by the square root method, and then we're going to identify the key features. So the square root method is where we're going to, if we can, take out any common factors, and then we're going to take the square root and solve for our x-intercepts. Before we do this, let's look at some key features of this function. So looking at f of x equals negative 2x squared plus 32. Looking at that function, that is already in standard form. So my form is standard. And because it's in standard form, I can say that the y-intercept is my c value, which in this case is 32. So I'm going to say that my y-intercept is 0, 32. Now it's asking for our solution, so that's what your x values are, and then your x-intercepts, that's when you actually put them as ordered pairs. So let's get into solving it. Is there a greatest common factor between negative 2x squared and 32? Yes. Remember, we want to make that a term positive if possible, so I'm going to actually take out a negative 2 from both of these terms. I'm going to rewrite my function now as negative 2 multiplied by x squared, and then 32 divided by negative 2 is going to give me negative 16. All right, so now it's saying to find my solutions. How do I do this? I set my function, so f of x equal to 0. So I'm going to say 0 equals negative 2 times x squared minus 16. And the first thing I can do to solve this is divide both sides by negative 2. 0 divided by anything is 0, so I'm going to go back up here and say that 0 equals x squared minus 16. In order to solve by the square root method, we want to isolate the term that is squared. So in this case, it's our x squared. In order to isolate that, we're going to have to add 16 to both sides. It's going to eliminate it there from the right-hand side. So we have 16 equals x squared. Then, solving by the square root method, I'm going to take the root of both sides. The square root of x squared is just going to give me x. But remember, because this is to the power of 2, we're going to have two answers here. So the square root of 16. Well, we know that 4 times 4 equals 16. So one of our answers is going to be positive 4. But negative 4 times negative 4 is also 16. So our answer here is going to be x equals plus or minus 4. So your solutions are x equals 4 and x equals a negative 4. And if I write those in intercept form, I'm going to have 4, 0 and negative 4, 0. Okay, let's look at example 2, so or B. So in this case, we have g of x equals x minus 2 squared minus 25. This is in vertex form. So since it's in vertex form, let's find the vertex. Your vertex is negative hk. In this case, inside the parentheses, I have negative 2. If I take the negative of negative 2, that's going to give me a positive 2 for my x value and negative 25 for my y value for the vertex. So just like we did the problem before, we're going to set this function equal to 0. There's no greatest common factor I have to remove for any of these. Notice the x is, its coefficient on x is 1, so we're good. So we're going to set g of x equal to 0. So we got x minus 2 squared minus 25 equals 0. So once again, we're going to want to isolate our squared term, which in this case is whatever's inside the parentheses. So I'm going to add 25 to both sides. So I have 25 equals x minus 2 squared. Now, we're on to where we can use the square root method. We can take the square root of both sides. So once again, like we did in problem A, when you take the square root of a perfect square, so we have 25, that's a perfect square, you're going to approach it from both the positive direction and the negative direction, because I know 5 times 5 is 25. Likewise, negative 5 times negative 5 is also 25. So I'm going to rewrite this now with the square root taken as, I'm going to flip it around just a little bit to make it easier for us to see, x minus 2 equals plus or minus 5. From here, I'm going to break, so this is not our solutions yet because we haven't isolated our x value, so we haven't isolated that x term. So let's break it into two separate equations. I'm going to have x minus 2 equals the positive 5, and x minus 2 equals the negative 5. Okay, so in both of those instances, I'm going to add 2 to both sides. So I have x equals 5 plus 2, which is 7. And then negative 5 plus 2, that means x is going to equal negative 3. Those are your solutions. X equals 7, x equals negative 3. And if I write them as x-intercepts or as ordered pairs, we know y, or our g of x, was 0, so the function was equal to 0. So I can say 7, 0, and negative 3, 0.